Today we are going to learn about Java operators. There are 6 operators: arithmetic operator, assignment operator, relational operator, logical operator, unary operator, and bitwise operator. We are going to learn one by one. First one is arithmetic operator. They are used for doing simple mathematical operation such as addition, subtraction, multiplication, division, and the last one will give you remainder, that is modulo operation. We can go to IntelliJ and do one program. Go to IntelliJ and we can create a new project, file, new project, and I'm going to give the name of the project as operators. Then click on create this window. So here SRC means source folder. We can create a new class here. So right click on source folder, new Java class. We are going to learn about arithmetic operator. So always class name should start with uppercase letter. So we are going to create a class called arithmetic operator. Now we need to write the main method because every Java program requires main method. Now we know that simple mathematical operation, like when we are adding two numbers, suppose 7 plus 3, we will be getting 10 as the output. In Java, to print a statement, we will be using system dot out dot println. So we can type 7 plus 3 and now we can run the program. Let's see what is the output we are getting. We will be getting 10 as the answer. We can move this to the right side, move to right bottom. Yeah, we are getting 10 as the answer. Now we can do similar mathematical operation when we click on Control and D for duplicating line. Control plus D. We can put minus, then we can put multiplication, then division, and the last one is modulo operation. And we know that 7 plus 3 will be giving 10 as the output. 7 minus 3 will be giving 4 as the output. 7 multiplied by 3, it will be 21. And the division thing I will tell you later. Now we can run the application and see. Yeah, we are getting 10, 4 and 21. Now for the division part, I will show you an example. Okay. For 7 by 3, if you are using division operator, we will be getting quotient. And if you are using the modulo operator, we will be getting remainder. I will show you with an example. Okay. We can go to the PPT and 7, when we divide by 3, 3 2s are 6 and we will be getting 1 as the remainder. So here 2 is the quotient and 1 is the remainder. For getting quotient, we should use the division operator, and for getting remainder, we should use modulo operator. So here for getting quotient, we should use the division operator and we will be getting 2. 2 is the quotient. And when we use modulo operator, we will get remainder. 1 is the remainder. So we have learned the first operator and these are the basic arithmetic operation. Now we are going to learn about the second operator, that is assignment operator. Below mentioned are the assignment operators. You can go to IntelliJ and I will show you with examples. So we can create a new class for assignment operator. Right click, new Java class, and we can name the class as assignment operator. Always class name should start with uppercase letter. Now I'm going to write the main method. Type main and then click on enter. That is a shortcut. Okay. Now assignment operator. Suppose think that there is a number 5. We need to store that number to a variable. I'm going to name the variable as a. Since this is a number, we need to use the data type int, integer number. Now always Java code should end with semicolon. Okay. So what we are doing is that we are assigning the value 5 to a variable a using the assignment operator equal to. So here we used the assignment operator equal to. I'm going to use one more variable b and I am going to assign value 6 to it. We are going to learn about the next assignment operator, that is plus equal to. Okay. So what I'm going to do is that I'm going to add b plus a. So the current value of b it is 6 and the current value of a it is 5. So we will be getting output as 11 and I'm going to store that in b. Okay. So b equal to b plus a. This is what I'm going to do. To print the output, we can write system.out.println. Instead of that, the short form it is type s out, then press enter. And I'm going to print the value of b. We know we will be getting the output as 11. Let's run the program and see we are getting the output as 11. So instead of writing like this, we can reduce this to plus equal to. So this assignment operator is same. Like this will be doing the same operation b plus a. So here also we will be getting the output as 11. Let's run the program and see. So instead of writing b equal to b plus a, see, instead of writing b equal to b plus a, this thing we can reduce like this, plus equal to. B equal to b minus a. Instead of writing like that, we can put minus sign before equal to sign. So we will be getting 6 minus 5, that is equal to 1. Let's run the program and see we are getting 1 as the output. Now instead of minus, the next operation, that is multiplication sign. So put multiplication sign before equal to, then we will be getting 6 multiplied by 5, that is 30. Now we can do similar kind of mathematical operation, division, modulo operation and all. When we put division operation, we will be getting the quotient. When we are putting the modulo operation, we will be getting remainder. So 6 by 5, the remainder it is 1. So instead of writing a equal to a plus b, this can be reduced like this. Similar for all the kind of mathematical operation. So these are the assignment operators. Now we are going to learn about relational operator. These are the relational operators. We can go to IntelliJ and learn with examples. So I'm going to create a new class for relational operator, new Java class, relational operator. Okay, now we can minimize this. Now we need to print an output. For that we can write sout. Sout is the short form of system.out.println. Okay. Now I am going to check whether two numbers are equal. I am going to use number 5 and number 6. If I am going to put only one equal to, that is an assignment operator. We need to write 2 equal to for checking the condition. 2 equal to means it is a relational operator. And this will return the output either true or false as the output. Either the answer will be true or false. These are Boolean values. Let's run the program and check. What do we think? 5 equal to 6. Are we going to get true or false? Let's run the program and we are getting the output as false because 5 is not equal to 6. Now equal to is the first relational operator. Now the second one is not equal to. Of course 5 is not equal to 6. Let's run the program and check whether we are getting true as the answer. We are getting true as the answer. Now the next relational operator it is greater than. 5 greater than 6. Is 5 greater than 6? Let's run the program and check. The answer is false. Now the next relational operator it is less than. 5 less than 6. Whether we are going to get true or false. We are getting true. Now I am going to put both the numbers as 5 and I am going to check whether they are greater. Okay. If I am going to use only greater sign, we will be getting false as the answer. We need to use greater than or equal to relational operator. Then only we will be getting true as the output. Now similarly, less than or equal to is also another relational operator, which will check whether the values is less than or equal to. See, we are getting true as the output. So these are the relational operator. We can do a simple program. Okay, int mark equal to 30, and I'm going to write an if else condition. If mark greater than, see, I'm using the relational operator here, mark greater than 50, then I'm going to print some passed, else I'm going to print some failed. Let's run the program and see what is the output that we are going to get. We have failed the exam. So we have used the relational operator greater than. We can change the mark to 60 and we can run the program and see the output. We have passed the exam. So this is the relational operator. Now the next one is logical operator. So there are three logical operators: and, or, and not. Here there are two expressions, expression 1 and expression 2. And suppose we are going to use logical and operation. Then if both the expression is true, then only we will get the output as true. For example, first expression it is 6 greater than 2. We know 6 is greater than 2. So that is true. Then the next expression is 7 greater than 2. 7 is also greater than 2. So that expression is also true. And if you are using logical and, if both the expression are true, then only we will get the output as true. For example, we can print the output by using sout. Sout is a short form. Then click on enter. We will get system.out.println. Now I am going to write two conditions. Okay. First one is 6 greater than 2, which is always true. And the next condition I am going to write 7 greater than 2. And I'm going to use the logical operator. I'm going to use the logical operator and. See, in this case, we will be getting either true or false as the output. What we are going to get here, first expression is true and second expression is also true. At that time, we will be getting the output as true. See, both the expressions are true. At that time, we will be getting output as true. Suppose think that one of the expression is false, like one condition is failing. At that time, if you are using logical and as the operator, we will getting false as the answer. At that time, we need to use logical or. If only one condition need to be true, at that condition we need to use logical or as the operator. Then we will be getting output as true. Now we can write one more. There is one more logical operator, that is not. Suppose think that 6 is greater than 2. Of course, we know the output that we are going to get will be true, right? I'm going to comment this. When I run the program, I'm going to get the output as true because 6 is greater than 2. Now, if I'm going to use the logical operator not, see, I have used the logical operator not. Even the condition is true, we will get the inverse of that. When I run the program, I'm going to get the output as false. See, this is the logical not operator. I will show you with an example. Suppose think that I have two marks. Mark 1 equal to 30 and mark 2 equal to 60. Now I am going to write one if else condition. If condition mark 1 greater than 50, and I am going to use the logical and operator. Mark 2 greater than 50, then some passed, otherwise exam failed. See, we have used logical and operator in a program. Let's run the program and see we have failed in the exam. Why we failed? Because one of the mark is less than 50. So I'm going to write this mark as 70. Then let's see whether we are passing. Yeah, the exam is passed. Now suppose think that only one condition is success or one condition is true. At that time we can use logical or as the operator. Okay. At that time we can use logical or operator. Then see your exam is passed. So the next one is unary operator. Suppose think that x plus y equal to result. Here x and y is the operand and plus is the operator. In unary operator, we will be using only one operand. Here two operand are there, but in unary operator, we will be using only one operand. These are the unary operators. Unary plus, minus, increment operator and decrement operator. We can go to IntelliJ and we can write one simple program, or I will show you with an example. Here we will be using only one operand. Okay. Suppose think that I have number 5. Okay. And I'm going to use the first unary operator, that is plus. If you write plus 5 here, or if you don't write plus 5, the value will be 5 itself, positive 5 only, right? So I'm going to print the output of x. The answer I'm going to get is 5, right? If I write plus 0, then also I'm going to get the output as 5 only. Now the next unary operator, it is minus. If I'm writing minus here, then I will be getting negative 5. Okay. Now the next unary operator, it is plus plus. This plus plus we can write here and also here, but not to a number. We need to write with a variable. I will show you with an example. I'm writing another variable y. See, as soon as I write here plus plus, I'm getting error. Okay, so we can't use with a number, we need to use with a variable. So I stored value 5 in x and I used another variable y, and I'm going to write plus plus x. See, now I'm not getting any error. If I'm using plus plus here, I'm getting error. We can't use the operator near a number. We need to use with a variable. Okay. Okay. Now I will show you what is pre-increment and post-increment. Writing plus plus before and also writing plus plus after. So suppose think that we have a value int x equal to 5. Now prefix is there, that means we are adding plus plus before x, and postfix is there, that means we are adding plus plus after x. Look at the changes that is going to happen on x and y. Okay, first of all, prefix, when we are adding plus plus before x, so the value of x will become plus plus, that means 1 plus x. So currently the exit is 5, so 1 plus 5, 1 plus 5, it is going to be 6. So the new value of x will be 6. Now what is going to happen for postfix? In postfix case, x plus plus, that means x plus 1. So the new value of x will be 5 plus 1, that is equal to 6. Now listen carefully, okay? The problem is going to happen for y. Y equal to plus plus x. Plus plus means first of all the increment is happening, that means 1 plus x. Increment is happening, then we are going to x. So 1 plus x, that means 1 plus 5, we will be getting 6. The value of y will be 6. But listen here, here the value of y will be equal to x. Why? Because here plus plus is after x. So x will be returned first, then only increment is happening. Okay, here increment is happening, then x will be returned. Increment is happening, then x will be returned. So increment already happened and we got 6 as the value. But here x is returned first. So y value will be 5 only. Okay, I will show you with example. Here increment is happening first, then returned. Here first of all x will be returned to y, then only increment will be happening. That's why y value will be 5. I will show you with example. I'm going to write plus plus before. Okay, so what is going to happen? I'm going to print both values, the value of x and also the value of y. X will be 5. Okay, so plus plus x means what is going to happen? We are going to get plus plus means 1 plus x value, it is 5, so we will be getting 6 as the answer. So here increment is happening, then x is returning, so the y value will be also equal to 6 because increment is happening then returning. So y value will be also equal to 6. Let's see whether we can run the program and see. See, we are getting both the values as 6, but when we are writing plus plus after, x value will be, see, x value will be x plus 1. So x it is 5. 5 plus 1, we will be getting 6. X value we will get a 6, but the problem is going to come for y value. Why? Because x is 5. It is already returned to y. Okay, so y will be equal to 5. X is 5. It is already returned to y. Then only increment is happening. Okay, so let's run the program and see. We are getting x value as 6 but y value as 5 because x is already returned. Then only we are incrementing. Similarly, there is minus minus operator. The same only, like plus plus. This will decrease the value. Now we can learn about bitwise operator. These are the bitwise operator. If there are two and, then it is logical operator. There is here is only one and, so it is a bitwise and. So for learning this, we need to have a small understanding of decimal to binary conversion and also binary to decimal conversion. I will tell you why. First of all, we can learn this conversion. We have a decimal number 4. We need to convert it into binary value. How we can do that? Binary means radix 2. So 4 divided by 2, we will be getting 2 as the quotient and 0 as the remainder. Then again we need to divide by 2. We will be getting 1 as the quotient and 0 as the remainder. Again divided by 2, we will be getting 0 as the quotient and 1 as the remainder. We need to do this operation. We need to always divide by 2 until we will be getting quotient 0 as the quotient. Then we need to write it in the reverse order from bottom to top. 1 0 0. 1 0 0 is the binary value of this decimal value 4. We can do one more example. We have a decimal value 6. We need to convert it into binary. So 6 divided by 2, we will be getting 3 as the quotient and 0 as the remainder. Again divided by 2, we will be getting 1 as the quotient and 1 as the remainder. Again divided by 2, we will be getting 0 as the quotient and 1 as the remainder. So remainder we need to write from bottom to top. That is 1 1 0. 1 1 0 is the binary of this decimal value 6. Now we are going to learn bitwise AND operator. Okay, so as we discussed, we have converted it into binary digit or bit values. Here it is 3 bit. 3 bits are there. So bit operation is going to happen. First of all, we are going to learn bitwise AND operation. So here AND operation, if both A and B is 1, then only we will be getting output as 1. In all the cases, output will be 0. Okay, so we have taken a decimal value 4. We already found that its binary representation is 100. Then the decimal value 6, we found that the binary representation is 110. If we are using logical AND operator, then we will be getting 100 as the output. 0 and 0, we will be getting 0. 0 and 1, also 0. If both are 1, then only we will be getting 1. If you are using AND operator, if both should be 1, then only we will be getting 1 as the output. This is the binary value. What is the decimal value of this? for finding decimal value 100. To find the decimal value, we need to know that 2 raised to power 2 raised to 0, 2 raised to 1, 2 raised to 2. So 0 multiplied by anything, it will be 0. So 0 multiplied by this, 0. 0 multiplied by this, it is also 0. 1 multiplied by 2 raised to 2. 1 multiplied by 2 raised to 2 means it is 4. So we will be getting 4 as the decimal value output. We have two numbers, x equal to 4 and y equal to 6. And first of all, we can use bitwise AND operation. Okay, so we are going to print the output, and bitwise AND means x, then we are using only one AND. If you are using two AND, it will become logical operator. We should use only one AND. Then y. So x and y. What will be the output we are going to get? Let's see. We can run the program and we can see the output we will be getting is 4. So for the binary value it is 1 0 0. For 6 the binary value it is 1 1 0. For the output we will be getting the binary value as 1 0 0. 1 0 0 means 4. So we are getting 4 as the output. Now we can learn bitwise OR operator. Here in OR operation, if any one of the two is 1, then we will be getting 1 as the output. 1 and 1, then we will be getting 1 as the output. Here 1 and 0, any one of it is 1. We will be getting 1 as the output. 0 and 1, we will be getting 1 as the output. 0 and 0, we will be getting 0 as the output. We have 4, decimal value it is 4, and we know the binary value of it is 100, and we have decimal value 6, the binary representation it is 110. If you are using OR operator, then 0 and 0 it will be 0, 0 and 1, any one it is 1, then we will be getting 1 as the output. 1 and 1, 1. So 110, the corresponding decimal value it is 6. Let's see whether we are getting 6 as the output. Go to IntelliJ, and we have two numbers 4 and 6, and we are going to use bitwise OR operator, and let's see whether we are getting 6 as the output. We can run the program and we can see we are getting 6 as the output. Why? Because any one it is 1, then we will be getting 1 as the output. We have used bitwise AND and bitwise OR. The next one it is bitwise XOR operator, exclusively OR. In this case, if both are 0 and both are 1, then we will be getting 0 as the output. If anyone is 1, we will be getting 1 as the output. If anyone is 1, then we will be getting 1 as the output. If both are same values, then we will be getting 0 as the output. So we have decimal value 4, the corresponding binary, 6, the corresponding binary it is this, and the corresponding output 0 and 0, 0. If anyone is 1, we will be getting 1. If both are same, we will be getting 0. So 0 and 0, the corresponding decimal value it is 2. We can see in program, we are going to use XOR operator. Then we should get the output as 2. Let's run the program and see whether we are getting output as 2. We are getting output as 2. Now the next one is bitwise complement operator. So we know decimal value for the corresponding binary is 100. Complement means the inverse of it. Inverse of 0 it is 1, 0 it is 1, and inverse of 1 it is 0. So the corresponding decimal value of 0 1 1 it is 3. Let's see whether we are getting 3 as the output. And bitwise complement operator we can use only for one operand. Okay. There are two operands x and y, but bitwise complement operator we can use only for one operand. So if you are using for, according to our program or according to what we learned, we should get the output as 3. That is binary representation it is 0 1 1. Let's see whether we are getting 3 as the output. We are not getting 3 as the output. We are getting -5. Why? For the binary value it is 1 0 0. So if you are using complement, then what it will be? Instead of 0 it will be 1, 0 it will be 1, instead of 1 it will be 0. What is the decimal value for this? What will be the decimal value? Here it is 2 raised to 0, 2 raised to 1, and 2 raised to 2. 0 multiplied by 2 raised to 2, we can cancel that because we are multiplying by 0. 1 multiplied by 2 raised to 1, 2 raised to 1 it is 2. So 2 plus 1 multiplied by 2 raised to 0, 2 raised to 0 it is 1. So we will get 3. 3 as the decimal value. But we are not getting output as 3. We are getting output as minus 5. How we are getting this? This 4 is a integer data type value. Integer means 4 byte. 4 byte means 4 into 8, it will be 32 bit. 32 bit. Here we are writing only 3 bit. We need to write 32 bit like this. So 100, 100, that is 3 bit. Like that we need to write up to 32 bit. And so first of all, this is 32-bit representation. Here we need to convert it into inverse one. Okay. So after converting it into inverse, the complement one, we understood that the initial digit, it is 1. That means this is a negative value. If it is negative, then the value is represented using 2's complement. To find 2's complement, first of all write the 1's complement. 1's complement means inverse of it. Then add 1 to it. So when we add 1 to it, we will get like this. So the final value we are getting as 5. Why minus 5? Because initially it was a negative number. So we are getting minus 5 as the output. Bitwise left shift. We know the decimal value, the corresponding binary representation is like this. And we are going to shift by one digit or one place. What is going to happen? The binary is going to shift towards left. And we need to add a 0 at this particular end, and we need to remove from here. So the final output will be like this: 1 0 0 0. What is the decimal value of this? It is 8. So we can go to the program and see shifting of a number x4. We are shifting to the left by one place. Okay, if you are writing 2 means 2 places. We are writing 1. So let's see what is the output we are going to get. We need to get the output as 8. See whether we are getting output as 8. See, we are getting output as 8. So this is left shift. Now the next one is by bitwise right shift. So right shift means we know decimal value 4. This is the binary representation. Right shift means shifting right by 1. So shifting right by 1. Then we need to add a 0 to this end and remove the extending end. So the final output will be like this. So the corresponding decimal value it is 2. Let's see whether we are getting 2. We are going to right shift by one place. So we should get the output as 2. Let's see whether we are getting output as 2. Now the next one is ternary operator. We have a condition. If that condition is true, then expression 1 will be the output. If the condition is false, then expression 2 will be the output. This is the syntax for writing the program. Condition, then put a question mark, then write expression 1, colon, then write the expression 2. For example, 5 greater than 2. We know that condition is true. 5 is always greater than 2. Then we are writing two expressions. So here we know that expression 1 will be the output. Then again we are going to write another example, 1 greater than 2. We know 1 is less than 2. So at this time we will get no as the output. We can go to Java and we can do an example for that, ternary operator. Ternary operator are used in order to remove or reduce if-else condition. Suppose think that I have a mark equal to 30. Okay, and I'm going to write one if-else condition. If mark greater than 50, then sout exam passed. Otherwise, the exam is failed. So this is the simple if-else condition program. This thing we can replace using a ternary operator. How we can do that? The same condition, write the same condition here. I'm going to write the condition, then put a question mark, then write the positive response or the positive expression. Copy that and paste it here, then put a colon, then write the negative case. Copy that and paste it here, then put a semicolon. Now here it is a string, so we need to store this to somewhere. So I'm going to write string result. Okay, and I'm going to print the result. So out result. So this is the example of a ternary operator. This if-else condition we can reduce by using simple ternary operator. Let's see whether we are getting the answer. Our mark is 30, so our exam is failed. If our mark is 80, then we have passed the exam. So this is the example of a ternary operator. We can directly copy this and write it here instead of using a variable. With one line we can get the output.